Hello to everybody. Good evening and welcome to our April AstroQuest from the Springfield Science Museum. My name's Kevin Kopczynski. I run the planetarium and do other STEM education here at the museum, and joined today by Rich Sanderson, the president of the Springfield Stars Club. So we have a nice program coming up for you. We'll have Rich is going to give us some information about a moment in history, a great moment in comet watching history, I should say. And then we'll go on to look at the night sky briefly, and then take a little bit of a look at the planet Mercury. Mercury is the most difficult of the visible planets to find. We're coming up on a good time to find it. So I like to give Mercury a little bit of love whenever those times come along, because it is a worthwhile target or worthwhile to try to observe. We'll start out with Rich Sanderson, president of the Springfield Stars Club. The club is just a wonderful ally here to us at the museum, helping us out with any programs that are astronomically related. We really appreciate that. So Rich, maybe you could tell us a little bit about the club, and then we'll get on to your images.
Well, thank you, Kevin. Yes, the Springfield Stars Club is an amateur astronomy club that's been around since 1934. We hold our meetings at the Springfield Science Museum on the fourth Tuesday of every month from September through May. And our meetings begin at 7 o'clock in the evening in the Tolman Auditorium, fourth Tuesday of every month. And it's a group of people of all ages, all levels of expertise, but with a common interest in science and astronomy and space exploration and different related topics. We don't get into anything too deep, no calculus and very few graphs. It's mostly popular astronomy, but it's something aimed at people that are either love astronomy, they're into it and do observing, or just have a curiosity about science and astronomy. And we have a meeting coming up a week from tonight, which will be the fourth Tuesday of April on the 26th. One of our great success stories is a young man named Adam Jermaine, who's been in the club since he was, 6 or 7 years old. And now he's a professional astronomer with a PhD who went to the Cambridge University in England, where Isaac Newton attended. And he's a professional. He's going to speak a week from tonight in the Tolman Auditorium about stars and how they're investigated using satellites that are orbiting the Earth, such as the new Webb Space Telescope and others. He's going to talk about how that research is being carried out in outer space as astronomers view the stars, which are distant suns, like our own sun, only so far away that they appear as pinpoints, and unless you have really sophisticated equipment, in which case then you can study them. And of course, one of the big interests is looking for planets circling these distant stars, and maybe Earth-like planets that might harbor life. So it's a pretty interesting topic. I've seen Adam speak before, and he's an excellent speaker, very interesting. I think everybody is going to enjoy that talk that attends the meeting. So that's a week from tonight at 7 o'clock at the Science Museum, and there's no charge. And if you're not a member, you're welcome to come. We don't check passwords or cards or anything at the door. Anybody can show up. Just come on down, and no charge. And we also, the Stars Club also participates in Stars Over Springfield, which is on the first Friday of every month. And that's a public observing evening that's conducted by the Science Museum with help from the Stars Club. And that's going to be on Friday, May 6th. And there's different speakers. Generally, Stars Club members contribute lectures, popular lectures, interesting aspects of astronomy, nothing too deep, as I said, aimed at the general public, and children, young people, family groups. And I'll be speaking in May because there's a lunar eclipse coming up, a total lunar eclipse on May 15th into the 16th, so the night of the 15th. And eclipses are one of my main interests all my life, solar and lunar eclipses, and I've seen quite a few. So I'll be explaining eclipses and showing pictures of past eclipses and discussing when and how to view the one on May 15th and 16th. So that'll be a total lunar eclipse, which is kind of a rare event. We get to see one every 3 or 4 years, you know, some get clouded out. So not super rare, but not common by any means. So with that, if you want to start up the images, I've got a couple of pictures I took recently of the Hubble Space Telescope orbiting overhead. And then as Kevin mentioned, I've got some pictures to celebrate a really spectacular sky display that happened a quarter of a century ago right now. And so we'll do that as well. So these are some pictures I took. There's actually 2 of them of the Hubble Space Telescope orbiting overhead. This was on April 2nd. And there's a really good website called Heavens Above, which you can go online. And again, it's free, and you can enter in your location, and it gives you a lot of information, including information about when the Hubble telescope, when the International Space Station is going to fly overhead, the ISS, and that's what this is a picture of. The ISS is the space station, you know, that has astronauts orbiting the Earth for years now, and it's a large object with big solar panels that reflects a lot of light. So when it goes over in a really favorable passover, it's one of the brightest objects in the heavens. So it doesn't take any kind of equipment to see, just your 2 eyes and just knowing when and where to look. And that's what Heavens Above can tell you. And oftentimes my buddy Brian Lapis on Channel 22 also tells us when there's going to be a good display of the space station passing overhead. So as I said, this was one that happened recently, and I got my camera set up ahead of time, aimed where I knew it was going to travel through the sky using Heavens Above. It gives you a map and the times of, you know, where and when it's going to be overhead. So you have to know the constellations a little bit. And I knew it was going to fly through Auriga and Gemini, the twins, and that's what these constellations are. Pollux and Castor are 2 bright stars in Gemini, and Capella is in Auriga, the charioteer. And I got my camera set, and when I saw that bright light coming at the exactly at the predicted time, I just opened the shutter and did about maybe a 1 minute long exposure. And the stars moved a little tiny bit. The stars are not pinpoints because the Earth turned a little tiny bit during that minute or so. But the space station was moving rapidly, and it was very bright, so it traced a line across the image while the shutter was open during that minute or 2 that I did the exposure. So it's a time exposure. It records movement as a line, but actually is a bright point of light going overhead. And the next picture shows the end of the passover of the space station. And what generally happens is the space station is best seen, as are any Earth orbiting satellites, right after sunset and right before sunrise. And most people are sleeping right before sunrise. So after sunset is the most popular time. And the reason that that's a good time to see satellites is because even though the Earth is darkened after the sun's been down, say 45 minutes or an hour, the Earth is dark, the sky is dark, the stars are out. But if you go up above the atmosphere where the space station is, the sun is still shining. And so the sun shines on the space station as it goes through the dark nighttime sky. So from the space station, it's still daytime, but from the surface of the Earth, where we're watching it, it's nighttime. And that's why it shows up so good right after sunset. So I think this was like about 45 minutes after sunset. And what this shows is the tail end of the journey through the night sky that night on April 2nd. And what you usually see is the space station eventually disappears. It just fades from view, and that's what this picture is showing. And just think of this as the sun has gone down in the west. It went down maybe an hour earlier. The Earth's shadow is rising in the east because the shadow of the Earth is opposite the sun. The Earth casts a shadow into space. That's what causes the lunar eclipse that's going to happen. And that shadow hits the space station as it's orbiting the Earth. The space station goes into the Earth's shadow and eventually fades away. And that's what this picture is showing. It's extremely bright, and then suddenly over about 5 or 6 seconds, it just faded to zero and disappeared as it plunged into the Earth's shadow. So it makes it a lot more interesting when you have an idea of what's going on. You can sort of visualize the Earth's shadow projected up into the sky right in that direction, and this satellite going right into it, and the astronauts seeing a beautiful sunset. Now, as Kevin alluded to, there was a beautiful comet in the sky 25 years ago. Right at this time, the world was abuzz with excitement, especially stargazers and amateur and professional astronomers, because this was a comet for the ages. It was named Comet Hale-Bopp. It was discovered by 2 American amateur astronomers, Alan Hale and Thomas Bopp. And when it was still far out in the solar system, it was the most distant comet ever discovered by amateur astronomers. The pros often pick up comets on photographic plates where they're detecting extremely faint objects, but this was the most distant comet found by amateur stargazers visually by just spotting it through a telescope. And it was still way out in the solar system. So that meant there was a good chance it was going to be a spectacle when it came around the sun in through the inner solar system, which is where we live, where the Earth orbits. And also the path of the comet, it sort of came in from below the Earth, and then it swung above the Earth's plane into the northern hemisphere sky. So it gave those of us living in the United States and basically north of the equator a front row seat for its brightest and most spectacular phase. And keep in mind, this was back in the days of film photography, when it was more difficult to get pictures of objects like comets than today with the sensitive digital cameras. And these are pictures taken on Ektachrome high-speed film, and the one on the right I took on Kodachrome 64, which is a slow-speed film for just daytime pictures. But the comet was so bright, you could get it with slow-speed film. It was so bright, people that didn't know anything about astronomy, living in New York City and in bright lights all around them, could see this comet in the sky. It was unbelievable. And you can see that the picture on the left was taken with Ektachrome film, which is more sensitive to blue light. And it shows the blue ion gas tail to the left. You can see that deep blue color to the left coming off of the head of the comet, and to the right, there's kind of a pinkish dust tail, which is reflected sunlight. So comets often have those two tails, the bluish ion tail and the orange or yellowish or pinkish dust tail. And Hale-Bopp displayed both brilliantly. It was a giant comet. It didn't come that close to the Earth, but it was so big that it provided a spectacular display for month after month after month as it moved through the nighttime sky. Next picture, Kevin. This was taken from a powder mill school, I believe. The Stars Club did a viewing session there, and there was so much excitement and hype. You know, the internet fueled it. The internet was going strong back in 1997. There was a lot of publicity about this comet, and people were anxious to see it. And we had a viewing session at Powder Mill School in Southwick, and it was mentioned in the paper, I guess, or on the news, and about 500 people showed up eager to see it. And you can see right over a brightly illuminated street with street lights and houses glaring, and there's the comet just jumping right out. a lot brighter than Comet Neowise and some of the more recent ones that we've seen. Next picture. I thought I would get a little fancy, and there's my refracting telescope that I used to take some of the pictures, and I got the comet in the background of the telescope. And that's not a double exposure or a Photoshop or anything. That's a single black and white picture on Tri-X film from back in the days of film photography. And what was neat about Comet Hale-Bopp, it broke all kinds of records, and the most important record was how long it was visible to the naked eye. That's an important statistic about comets. The previous record holder was the Great Comet of 1811, almost 200 years earlier, was visible for 9 months to the naked eye, and that was like one of the greatest comets ever seen. Comet Hale-Bopp not only broke that record, it shattered it, it doubled that record. 18 months, from 9 months to 18 months, Hale-Bopp was visible to the naked eye. And I like to say that that's similar to an Olympic runner running the mile in 2 minutes, breaking the record by that much. That's what Hale-Bopp did. It broke a record that was almost 200 years old, and it shattered that record. I mean, Hale-Bopp probably won't be eclipsed for 1,000 years. You know, it was such a great display, but nobody knows for sure. Next picture. The thing with comets is they're always being discovered, and you never know if there's another Hale-Bopp right around the corner. But statistically, comets like Hale-Bopp are extremely, extremely rare. That was like one of the best comets of the millennium. Now, this is a picture that I took through my telescope, zooming in on the head of the comet. The tail is asymmetrical because the comet is like a big ball of ice with dirt and dust mixed in, sort of like a dirty snowball, and it's tumbling. And the side that's facing the sun heats up, and then as it tumbles away from the sun, geysers of gas shoot out from this dirty iceberg, and the ice vaporizes, and the geysers of gas shoot out and form a tail. And it's you can see that the comet in this picture is rotating counterclockwise, so it's facing the sun at the bottom because the tail always points away from the sun. And then as it rotates past the sun, the active part is streaming gas into the tail. So the right-hand portion of the tail is brighter because that's the part that's coming off the head, the solid nucleus of the comet that's just been heated up by the sun. So there's a nucleus that it's like dozens of miles wide at the core. Then there's that bright head of gas, and then the tail that's blown back by the solar wind and the pressure of sunlight hitting the comet. Next. Now, this was a beautiful night. I think this was out near Proven Mountain. It's a picture of the moon, the Pleiades star cluster, and Comet Hale-Bopp on the far right. The moon is on the left. It's actually a thin crescent moon, but this is a time exposure to show the comet and its tail. So the moon is overexposed. And the moon is right inside a V, a tiny V shape of stars, which is the head of Taurus the bull. It's called the Hyades cluster. And the moon is right there. And then to the right and down a bit, you can see a little tight clump of stars. That's the Pleiades star cluster, which is in Taurus the bull. And then on the far right is Comet Hale-Bopp with its little stubby tail. It was starting to get a little dimmer at this point, moving away from the sun. And to the upper right of the comet, the tail appears to be touching a bright star, and that's Algol, the demon star, which is a famous variable star that changes brightness periodically. Next picture. And this is one of the last pictures I got of Comet Hale-Bopp as it was moving away. It moved into the southern sky finally after the northern hemisphere got this spectacular months and months of viewing. It moved into the southern sky, but at that point it was moving away from the sun and getting dimmer. And you can see it's not showing its former glory, but still a beautiful naked eye comet with a tail in the evening sky. I took this from out in Munson. This comet is a long, long cigar-shaped orbit going way out beyond Uranus and Neptune and Pluto, out into the outer reaches of the solar system. but it is orbiting around the sun. It's a member of our solar system, and that chunk of ice will one day swing back into the inner solar system, but not until the year 4385. Imagine that, 4385. It's like a traveler that's going to pay a return someday, and you wonder, we saw it 25 years ago. What will the Earth be like when it comes back? It just makes you think about the flow of time and the clockwork precision of the solar system, that we can determine to the year precisely when this visitor is going to return again. And hopefully there'll be people on the Earth to see it in the year 4385. So that's a little trip down memory lane of an event that was really important in my life. I probably never see another comet quite like Hale-Bopp, and I'll certainly never forget it. And during that time, I was in big demand. We did so many programs for outreach for people. Everybody was interested. Everybody wanted to see it. We were doing programs at museums and libraries and schools and different places all over Western Massachusetts. And what an exciting time. Kevin, you must have done some observing of that, right?
Absolutely. I actually got I got some nice pictures. I was living out in Warren at the time. It was pretty. It was a nice a fairly dark area considering, and those are. Well, okay, I was about to say those are my only comet pictures, but I did get a couple of neo-ice actually. So, but certainly Hale-Bopp looked a lot better. The gas tail was amazing, and just to have that thing just hanging up in the sky, you just get that sense that there's something different up there that you don't see all the time, and you understand why ancient people felt very uneasy about the presence of comets, because they were things that disrupted the order of the solar system or of the night sky. So thanks, Rich, for that trip down memory lane. I do want to mention, while we are enjoying a view of the current night sky, I do want to mention that in addition to Stars Over Springfield on the 6th, we have Astronomy Day on May 7th, Saturday. Astronomy Day is a day of celebration or observing that is held once in the spring, once in the fall. The museums usually do something for the spring occurrence, and it's a time where it's set for a time when it's a first quarter moon, so the moon is out during the day, so you've got a lot of chances for observing, hopefully if it's clear. So we are planning to have some special events, some extra activities, astronomy activities around the museum that day. We have a guest speaker from the Smithsonian Astrophysical Observatory who's going to come and talk to us about the sun and the Parker Space Probe, the Parker Solar Probe that is currently approaching the sun and beginning to return some interesting results. There will be our usual slate of planetarium shows. We should have a nice presentation about our meteorite collection, and hopefully it'll be the weather will be clear, and we'll have some telescopes set up where we can safely view sunspots or the moon. Hopefully you can make it to there if you're not too worn out from going to Stars Over Springfield the night before. Definitely going to be a very, very busy couple of days for me, but definitely looking forward to it. Let's get on to think about just some events in the night sky. Again, we're looking at a current view. This is set for somewhere around 8:30, and we're looking west, and notice that even around 8:30, it's not totally dark. You still got that little glow, a little glow of daylight out there in the west, and you can see very low Mercury down there set in the western sky, and that's what we're looking at. One thing is that you can see it's very low right now. It will get higher and higher at the onset of darkness over the next week or so. So this is, again, a good chance to look at it. And I'll show you a couple pictures of why these chances only come around every so often. We see Orion over here, the hunter, Orion the hunter, and looking now, coming down to the western horizon. We've been looking at that ever since December, where it came up in the eastern sky. It slowly made its way across, and now as we get into toward the end of April and into May, it's down on the western horizon. It's twilight out there. The sky is got a little brightness to it, and Orion has lost a lot of its glory because of that, but it's still hanging in there. To the right, we have Aldebaran and Taurus the bull, and slightly to the right of that, the Pleiades star cluster. This time of year brings to mind one interpretation from Native Americans of the Southwest, that as we go, and let's go ahead and step through and do that. As we step through day by day, we see Mercury getting higher, but we also see the Pleiades getting lower. We see the sky getting brighter because the sun sets later. We can turn the time back a little, but the Pleiades are getting lower and lower, and these were called the seed stars because these stars planted themselves in the horizon right about at the time when it was time to plant the seeds, the corn seeds. So we have a little reminder of that right now. To the left of Orion, the great star Sirius, the brightest star in our night sky. Let's head over to the eastern sky. And in the eastern sky, we've been watching Leo coming up at us, and also Boötes. I'm getting the Big Dipper into the picture. You're getting a little bit more to the northwest. The Big Dipper is getting up higher into the sky. Remember, it was skirting the horizon, right, last fall and into early winter. Now it's rising high in the sky, and the arc of its handle comes around to the star Arcturus, part of the constellation Boötes the hunter. Boötes the herdsman. Our phrase in star watching is we say follow the arc to Arcturus, and then we can speed on to Spica. Spica is the brightest star in the constellation Virgo. Virgo is up in this area. Virgo is one of those ones that bears practically no resemblance, if any, to what it's supposed to represent. Virgo is a harvest goddess, but it actually has to do with this star and its position and its role in informing when it might be time, in this case, to plant crops. And in this case, what you look for is first, you look for Spica. I think it needs to be a little higher than it is, but you look for it to be maybe halfway into the western sky, and halfway up into the eastern sky, and that is about planting time as well. That's another tradition for planting time. So this star told you when to plant your crops. Later in the fall, as it approaches alignment with the sun, that gets to be harvest time. So it lets you know when to harvest your crops, and this area becomes a harvest goddess, even though it doesn't look like that. Yeah, and then Gregory in the chat, yeah, thank you. And so, right, to complete the phrase, arc to Arcturus, speed on to Spica. Some people say spike to Spica, and then curve, make a curve. And there's Corvus the crow. So another one that doesn't look too much like a crow. Maybe a head, a wing, and a tail. And I think I've mentioned before, they really weren't trying to make pictures with these things. They were trying to make a system of putting things together that made sense to help them remember things. Maybe this crow was going after this seed of, actually this represents wheat. Spica is represents a grain of wheat. These are the constellations coming at us in the eastern sky, and then moving up higher into that, maybe more to the southeastern sky, we've got Leo the lion. All right, this one does have some resemblance. We have a round area for a head, the front of the lion with the bright star on its chest, two stars on the rear end, and a star on the tail. So we have a head, the body, and a tail. I like to think that the lion is crouching and we do not see legs. So we'll see that getting higher as well as the weeks go on. Let's go ahead and shift to the morning sky, because that's where we're going to have something interesting coming up. I was on the 24th. I wasn't on, but that we did move it ahead a little bit. And we'll go back to the 22nd, and then let's go to the morning sky, somewhere maybe around we can start to see the planets coming in at us. Let's go a little bit later, and we'll start to get to be dawn. And we see that in the morning sky, we have quite a lineup of planets. Basically, everyone but Mercury is out there in the morning sky. And this is a prelude. Later this year, Mercury will swing around to the morning sky and join this crew. And we'll have quite really a great lineup. So and then this is the 23rd, we see there's the moon, but then on the 24th, the 25th, and the 26th, the moon sort of approaches all of this. Venus and Jupiter are fairly bright, so they'll be able to sort of fight against the oncoming dawn. So you might want to think about, if you're going to try this, first of all, if you're going to try this, you really need a clear eastern horizon, a fairly good clear eastern horizon. And then it's going to be a race for Venus and Jupiter to get up high enough before the sunlight gets too bright. But again, they're bright enough to compete. That should be kind of a cool planet show to look for in just coming up, basically starting this weekend. So you get up early, come on over to Astronomy Day, and keep looking for this. And hopefully one of those days will be clear anyway. Okay, so there's some things we can look at in the night sky. Mercury, again, you don't get to see it too often. I have here's a couple of images of the solar system. And we see the Earth, Mercury, and the Sun. And as the planets orbit, and we'll just think about Mercury and the Earth anyway, as they orbit, Mercury appears in the sky to be a certain distance away from the Sun. We call that its elongation. And we can see on the right-hand picture, we can see a very favorable elongation, that the apparent angle, the angle between the line to the Sun and the line to Venus, the line to Mercury, that angle is a very great angle. And that's one thing that we have going for us right now, whereas other times the angle is very small. But then the other thing is not just that angle, but now we're coming back to, this is recorded screenshots from Stellarium. By the way, I really should put a plug in for Stellarium. It's a free program. People do that as just a project of something that they want to put out there for everybody to enjoy. So you can, it's a free download and free to use on any computer. And I believe they do have some mobile versions available as well, some phone or tablet versions. Well, what we see is, so the line that you see going through these pictures, this line is the line of the ecliptic, the plane of the orbit of the planets as seen from the Earth. And we can see, and these are two different evenings, two different times of the year, and we can see that that ecliptic tilts at a different angle depending on the time of year and whether you're looking in the morning or the afternoon, the morning or the evening. On the left is of favorable conditions, a favorable tilt where the tilt is straight up, and that means we have Mercury there. Notice how Mercury is kind of far off that ecliptic line. Mercury is the furthest off of the ecliptic of the planets. And if it wasn't for that, the ecliptic would be a lot tighter. It's because this is tilted up, Mercury gets to be high above the horizon and easier to see. Mercury is a fairly bright object. It also competes reasonably well with the sun, with the glow of the sunlight. However, I just do want to mention, make sure the sun has set before, if you're going to use binoculars, make sure the sun has set before you look in that direction. Okay, that's very, very important. And really, before the sun sets, Mercury is good, but it's not that good. You do have to wait until after the sun sets anyway to be able to see it. So there, and just on the right now, we have a very unfavorable situation where the ecliptic is very shallow to the horizon. So even though Mercury might be a fairly good elongation from the sun, it's a very poor elevation above the horizon. So we have both the good tilt and the good elongation going for us, starting right about now and going for another week or so. It's not that it's impossible to see Mercury again for the year. This is just the best chance where these two factors come together very favorably. Mercury, as we know, it's the closest to the sun. I think I've got, here's a comparison. It's the closest to the sun, so the sun is going to appear larger in the sky than it does here on Earth. And the figure I've seen is approximately 3 times what the apparent size is to us on Earth. But Mercury also has the most elliptical orbit. In other words, the orbit that looks most like an ellipse, elongated, the largest relative difference between its closest point and its furthest point from the sun. So this is showing us a comparison of the two. This is roughly what it would look like from more or less the same spot on Mercury. But on the left, we have Mercury at perihelion, at aphelion, furthest from the sun. And on the right, it's closest to the sun at perihelion, and the sun looks even larger. So it depends a lot on that. Well, it's Mercury, as you may know, has a very interesting orbit. There's a locking in its orbit where Mercury basically has 3 rotations, what we might a day, and I'm going to put that in quotes as we're going to see in a moment, 3 rotations for every 2 trips around the sun every 2 years. It's got this 3 to 2, and that leads to some very interesting effects. And then especially when you couple it with the idea that there's this large difference between closest and nearest point, and that means there's a large difference in its orbital speed. When it's further away, it's moving slower than at its closest. And all of these, so these factors come together. So why I said day and kind of qualified that is, if we think of a day as a period from sunrise to sunset, well, that day is actually 176. That you would, that's the amount for Earth days of 176 24-hour periods, let's say, right? That the moon would be, the sun would be visible on the planet. So that is another interesting effect. And then as that speeds up and slows down and it's turning, what happens is that you may know that it's a hot planet. Its temperatures can get up to 800 degrees on the lit side. It's minus 300 degrees or so, 330 on the unlit side. At nighttime, but there's actually variations, and unlike on the Earth, we think of our temperature variations that from north to south, right, from the equator. Well, because of this slowing down and sometimes speeding up of the motion around the Earth and that slow turning of the daily motion, some longitudes of Mercury get hotter than others when the sun is over them. And it can be quite a difference, like almost twice as much. There's certain longitudes, certain longitudes where that would be almost twice as hot as a longitude that's about 90 degrees or a quarter of the way around the Mercury's globe from that point. So it would be a most curious place, of course, a very difficult place to have any kind of a outpost, any kind of an outpost for people to try to live there. And yet, saying that, it's not maybe incredibly out of the question either. So coupled with all that, the tilt of Mercury is almost straight up. It's about 2 degrees off. So the tilt, it's almost straight up and down. This is a view of the North. I'm pretty sure it's the North Pole. It's one of the poles. So that the light is coming in from the side all the time. And these deep craters are in shadow all of the time. First noticed by the now collapsed Arecibo telescope in Puerto Rico, and later confirmed by, this is a picture from the Messenger mission that orbited around Mercury, that there are deposits of ice. So these bright areas represent areas of deep shadow where other spectroscopic instruments have detected water. And it's actually fairly deep. It seems to be fairly deep deposits. They think there's more water here and then down on the other pole than actually that might exist on the moon, in the moon's deep craters. So it's sort of a permanent freeze up there. They think that the water comes from, as you imagine, this planet is being really bombarded with strong solar radiation, and that creates free protons, which can combine with some minerals in the crust and actually form water molecules. And should one of those water molecules drift up and into this crater, it'll freeze and it won't come out again. And they think that's been happening for much of the life of the planet. So even though it's so hot, it's right next to the sun, so to speak, there's actually water up there. All right, let's just do one final thing, and I'm going to have to do a reshare, and we'll take a close-up look. Thanks to a program called Open Space. And this is one that we've used to visit the moon. We've used it to visit Mars. Well, it has a pretty good representation of Mercury that the messenger gave us some really good views of Mercury, and gave us some good mapping abilities there. All right, so we've got a view. This is one of the craters on Mercury. Again, and this is a view from Open Space. I kind of navigated to that ahead of time so that we had a little more time to look at it. And this is a special crater, at least kind of special to those of us here at the museums. Now, there's different naming conventions for features on the different planets of the solar system. And on Mercury, the naming convention is to name features after various artists, and it could be in any genre. So there's a Beethoven crater and so on. But this crater that we're looking at is actually the Zeus. They found a crater to name after Dr. Seuss. So we're having a good close-up look at that. See if we can, yeah, we can, there we go. We can get a little closer now. And this is a fairly recent crater. We can see a fairly large central peak. So the impactor, this was a larger impactor, made a deeper hole, which then kind of, the material rose up after the impact and then kind of slumped down again and rose up into the middle as an impact, as a central crater. The area around the craters is still fairly sharp ridges, so it hasn't erased that much. Unfortunately, there's not a whole lot of detail on this crater, so I don't know exactly how old it is. But these features, the central mountain is not worn down all that much. It is a fairly recent crater. It has a lot of lava flows on it and a lot of different minerals, so that when the cameras take images, this is a straight image, so to speak. When the cameras take images of this with different filters to look at different elements, there's some interesting color to it as well, and that's what inspired them to name this after Dr. Seuss. So for those of us here at the museum anyway, again, sort of a special crater that I thought we'd come in and end up with a look at on our visit to Mercury tonight. So thanks to everyone for coming by today. And we'll also look forward to seeing you perhaps at our next AstroQuest in June on the third Tuesday. Otherwise, hope to see you maybe at Stars Over Springfield, at the Stars Club meeting, or at Astronomy Day. Everyone have a great evening. Rich, thank you very much again for your wonderful help.
My pleasure.
Okay, and we'll see everyone next month.
Okay, good night, folks.